Can you introduce yourself?
Hello, my name is Hadi CHEHADE. I am a doctor engineer in telecommunications and computer science, specializing in RFID. I conducted my doctoral research focusing on this technology, specifically by characterizing and evaluating RFID tags that are situated over the air. That means succeeding in characterizing and evaluating RFID tags without physical contact with the tags, without a line of transmission, just by communicating with the RFID tag remotely.
What exactly is an RFID tag, and what are the different types that exist?
An RFID tag is a small electronic label device that identifies an object at a distance using RF radio waves. We distinguish three main families of RFID tags. Passive tags have no battery and are powered exclusively from the radio frequency reader signal. We also have active tags that come with a built-in battery. They can transmit further and store more information. The third family is semi-passive or semi-active, we can say. They possess a small internal battery solely for powering the chip, but they communicate like a passive tag. There is also a new generation in development, the chipless RFID tags. Unlike the others, they do not have an electronic chip. Identification is done solely by the electromagnetic signature of the antenna. It is still a research and development technology, but it enables costs that are even lower than those of the passive RFID tag.
What are the main components of a passive RFID tag?
A passive RFID tag is very simple. We have an example here. We have an antenna frequently constructed from aluminum or copper, which is presented here, the large antenna there, and an electronic chip, which is in the center. It is a microcircuit. These two elements are placed on a paper or plastic inlay. Despite its simplicity, this diode is very powerful and that composes an RFID tag.
What role does the antenna play in RFID communication?
The RFID antenna serves two crucial functions. It captures the energy transmitted by the reader in order to power the chip. It also serves as a communication channel. That means it receives and sends back radio signals. The antenna's shape and size significantly affect the reading range and reliability, because it either reduces or increases the antenna gain, and as a result, it changes the reading range in a communication between the reader and the RFID tag.
And what does the chip do?
The chip is essentially the brain of the tag. It contains a unique identifier, often called EPC, electronic product code, and a small memory to store additional information. It also manages the dialogue with the reader by adhering to a standardized communication protocol known as EPC Gen 2, which defines how the tag and the reader communicate, how we read, we write, and even use the data in RFID tags.
How does the passive tag capture energy?
The principle is electromagnetic induction. The reader transmits a radio wave, and the tag's antenna captures this wave and converts it into enough electrical energy to activate the chip. It is somewhat similar to charging a phone wirelessly, except that here the energy is minimal and only serves to power the chip.
How does communication between a tag and a reader work?
Communication between a tag and a reader happens in two steps or two links. Reader to tag link, this is what we call the forward link, and tag to reader, which is called the backward link. The forward link then is when the reader transmits a radio signal toward the tag. This signal has two functions. First, it powers the passive tag by means of the antenna capturing the electromagnetic energy, by absorbing a portion of this energy. The tag only becomes active once it reaches a specific energy threshold, which we call the sensitivity threshold, the tag's sensitivity. For recent tags, for example, this threshold is about 24 dBm, which equates to a very faint signal, yet enough to initiate the chip's operation. After the tag has been activated, it is then able to interpret the commands that are being sent by the reader device, like writing in the tag, reply back to the reader, write to the memory, etc. The second link is the backward link. After the tag is activated, the tag transmits its reply by reflecting and modulating the received signal. This is the principle known as backscattering. By modulating its antenna, it is able to transmit its identification and other data back to the reader.
Do all tags work on the same principle? Or does it depend on the operating frequency?
The general principle is the same, but of course it depends on the frequency. The low frequency, or LF RFID, is often used for access and for animals at short range. Conversely, the high frequency, or HF RFID, like NFC for example, is used for contactless cards, passports, and the third frequency mode is UHF, ultra high frequency, used in logistics and supply chain.
What information can be stored in an RFID tag? Can it be changed? And what is the difference between it and a barcode?
We can store a unique identifier, but also other data depending on the tag's memory. For instance, a serial number, a date of manufacture, a manufacturing batch, etc. We can modify or rewrite part of this data if the tag is programmable. The distinction from a barcode is that RFID does not necessitate a direct line of sight. It is quicker, and we can read multiple objects at the same time. It is also programmable.
Is there a simple analogy we can use to explain this to someone who knows nothing about electronics?
Well then, imagine a magic mirror as an illustration. The reader acts like a flashlight that lights up the tag, and the tag, conversely, is a small mirror. When it receives the light from the reader, from the flashlight that shines, it reflects a specific gleam matching its ID, the tag's ID, which is the small mirror. That is precisely the way it works, like a passive RFID tag, but with RF waves.